Hello, Honors Math 3. Thanks for tuning in. Today is Thursday, April 16th. Just a reminder, I put this in our Skyward message this morning. We are going to have a Zoom meeting today at 2 o'clock. If you have any questions at all in Chapter 14 so far, or any questions with how class is going, the info for that Zoom meeting is in Skyward's assignment today. Alrighty, so no pressure, but if you want to tune in, I will be here today at 2 o'clock. Alrighty. Yesterday we saw Tuesday we saw some algebraic properties of limits. I saved finding the limit of a quotient just because if you remember with division some strange things happen. This means I can find the limit as x approaches some constant of a quotient of two functions, f of x divided by g of x, two different functions. That is the same as the limit as x approaches c of f of x divided by the limit as x approaches c of that function g of x. But again, strange things happen with that denominator. This property is true as long as the limit as x approaches c of g of x, that limit value in the denominator, is not equal to 0. Alright, so we just have to be a little bit careful that that limit in the denominator is not equal to 0. Let's try a few of these quotients, limits of quotients. If I try to find the limit as x approaches 2, and again, it's a little helpful if you can print off these notes and fill them in. I understand if you can't, but at least if you can print these and fill them in, you would have something to look at as you do your homework. You don't have to print the textbook pages, they're just there for you as a reference. Let's see. And everyone's submitting their homework, no problem, so I'm getting your homework and checking it in. Alrighty, let's see, find the limit as x approaches 2 of this quotient. That is the same as, from up above, the limit as x approaches 2 of that function in the numerator, x squared plus 2x minus 5, divided by the limit as x approaches 2 of that function in the denominator, which is x squared plus 1. I don't know if it's more clear if we put parentheses around this. Alrighty, is there any problem with this denominator? As x approaches 2, is this approaching 0? No. As x approaches 2, 2 squared is 4 plus 1 is 5. The value of the limit in the denominator. If I plug in 2 to the numerator, what is that? If I plug in 2, that is 4 plus 4, which is 8, minus 5, which is 3, and the value of that limit is 3/5. If you notice right here that that denominator is not equal to 0, we could have just said that's the limit as x approaches 2 of, you can plug 2 in, yeah, perfectly fine in the denominator, perfectly fine in the numerator. So you don't have to separate x squared plus 2x minus 5, x squared plus 1. If you notice that that's okay, we could have just said that's 5, that's 3. You don't have to separate. Alrighty. But if we notice right away that if I plug in -1 into this next limit, if I chose to separate, that denominator becomes the limit as x approaches -1 of x squared minus 1. So if I kind of look ahead, if I plug in -1, -1 squared is 1, minus 1 is 0, that denominator is going to equal 0. And I'm going to have a problem. Alright, so I'm going to right away try to fix that problem spot. I know that that limit in the denominator is going to equal 0. I know I'm going to have a problem, so let's try to fix that problem. A typical way to fix that problem is to factor. I factor and remove that problem. Okay, so let's see what happens when I factor inside that limit. This becomes the limit as x approaches -1. Factor out an x up top, x times x plus 1, divided by, factor the denominator. You can pause any time and practice that factoring. But notice that denominator is a difference of squares. Factors to x plus 1, x minus 1. I have a common factor And that just eliminated where that 0 is going to occur in the denominator. I simplify that function inside my limit. This becomes the limit as x approaches -1. Numerator, I'm left with x. Denominator, I'm left with x minus 1. You can separate that into a quotient of limits if you want. But at this point, since I'm not getting a 0 in the denominator, I can just plug it in. If I plug in -1 up top, I get -1. Plug in -1 in the denominator, I get -2. And those function values are approaching 1/2. This is a rational function. As x values approach -1, the function values are approaching 1/2. It is undefined. That function is undefined at -1, but that's okay. I don't want the function values when x is equal to -1. I want function values as x gets close to -1, and my function values are approaching 1/2. I don't know if you remember with a rational function what happened on the graph when I had that common factor that I could eliminate. Do you remember that was a hole in the graph? So I'm going to have a hole in that graph at x equals -1. That's okay. The function values are approaching 1/2. Pretty cool. That was from our rational functions. Alrighty, if you were asked to find or evaluate this limit, what is this limit as x approaches 2 of this complicated rational function? If you want to take a moment and plug in 2 to the denominator, you can. If you plug in 2 in the denominator, I can do that quickly. That's going to be 16. What is that? 8 times -2 minus 16. 2 plus 2 minus 2. That denominator is equal to 0. So I know I'm going to have a problem, and this limit is going to be, that denominator is going to be undefined at x equals 2. Okay, so let's try to remove that problem. Later on, we're going to call this removable discontinuity for limits. I have some removable discontinuity. All right, if I want to remove that, the first thing I try is to factor. Please pause the video and try to factor the numerator and the denominator. Okay, to factor the numerator and the denominator, I need to factor by grouping. I group in the numerator. In those first two terms, I take out an x squared, and I'm left with x minus 2. Out of those second two terms, I factor out a positive 4, and I'm left with x minus 2. I'm going to group in the denominator. Out of those first two terms, I'm going to take out an x cubed, be left with an x minus 2. And in those second two terms, I don't have to take out anything. Sometimes I just call that plus 1 times x minus 2. All right, what does this become? This becomes the limit as x approaches 2. Now I can take out an x minus 2 from both terms in the numerator, and I'm left with x squared plus 4. In the denominator, when I factor out that x minus 2, I'm left with x cubed plus 1. Hey, I just eliminated that problem spot. There is a hole in the graph of this rational function at x equals 2. Later on, again, we're going to call this removable discontinuity. That function is discontinuous at that point. There is a hole, but that's okay. My function values are approaching what? Now when I plug in 2 to the numerator, that's 2 squared, which is 4, plus 4, which is 8. Plug in 2 to the denominator, that's 2 to the third. 2 cubed is 8, plus 1 is 9. My function values are approaching 8/9, even though that function is actually undefined at x equals 2. That's okay. Alrighty. Pause for a moment as we move. Okay, here's a good calculus concept. Find the limit as my x values approach 3 of the average rate of change of this function from 3 to x. What on earth is average rate of change? If you remember, average rate of change is really just a fancy way of saying slope. Okay, this is weird. How are we going to find the slope of this thing as x values approach 3? I always like to have an idea of what I'm finding. What does f of x equals x cubed look like? F of x equals x cubed was this little squiggle graph, if you remember. There's f of x is equal to x cubed. What happens to the slope as x values get close to 3? As x values get, okay, now this is weird. Finding the slope of a curve, we're going to find the slope of this curve. If I could just skim a line along that as I get closer and closer and closer to x equals 3, closer and closer and closer, what's the slope approaching? We can't find the slope of a curve, but if my x values get closer and closer and closer and closer, it's like approximating the slope of that curve at that point. Does that slope look like it's going to be positive or negative? Let's try to find it. How do I find slope? To find the slope, that's just a change in y over change in x. Or, here's my change in y. Change in outputs over change in inputs. Change in y over change in x, or the change in outputs over the change in inputs. Okay, so let's think about that for this function, f of x equals x cubed. I'm going to find the limit as my x values approach 3 of the average rate of change, which is the slope, which is a change in y over change in x. In this case, it's going to be f of x minus f of 3 as my x values get closer to 3. As x values get closer to 3, what does my slope become? Okay, so I think of things this way. As x values get closer to 3, there they are, the average rate of change, or the slope, is approaching what as my x values get closer and closer and closer? What is f of x? F of x is x cubed minus, change in y up here, f of 3. f of 3 is 3 to the third, which is 27, all over my x values approaching 3. I can't plug in 3. It's undefined for x equals 3. So I need to do a little bit of work, and I'm going to factor. What's the limit as x approaches 3 of, pause if you would, and factor the numerator. Look at factoring that numerator. That's a SOAP pattern. One of those. Sign stays the same. One of those. What cubed gives you 27? 3. Remember to get that second term, which is always a trinomial, square the first, multiply those together, and change the sign, and then square the last, which is plus 9. Well, would you look at that? I can remove that problem spot, and this becomes, now I can plug in 3. 3 squared, which is 9, plus 3 times 3, which is 9, plus 9, and the average rate of change, the slope, is approaching 27. And would you look at that? It's a very steep slope right there at x equals 3. Let's try that one more time. Find the limit as x approaches negative 1 of the average rate of change of this function. What is the limit as x approaches negative 1 of the average rate of change? That's a slope. So I'm going to plug into the slope formula, which is a change in y over change in x. What's the change in x? That's x minus a negative 1. What's the change in y? That's the change in the outputs for any x value getting closer and closer and closer to negative 1. Again, as x values approach negative 1, the average rate of change approaches what? That's the limit as x approaches negative 1. My function itself, which is 2x squared minus 3x minus f of negative 1. Could you pause for a second and find f of negative 1, please? Minus f of negative 1, which comes out to be 5, so minus 5. I can't plug in negative 1, so please pause and factor. I factor that numerator. I remove that problem spot. I plug in negative 1, and I get a slope of negative 7. And here's your food for thought if you want to picture that function. and that's